Okay, today we're going to learn how to write nuclear reactions. So with nuclear reactions, we don't actually care if the elements are the same amount on each side. What we care about is the total number of protons and neutrons. So in other words, the atomic number on the bottom and the mass number on the top need to add up to the same totals on both sides. There are 5 different types of particles. There's alpha particles. Here's the little summary. Alpha particle, which is a helium 4-2. Beta particle, which is essentially an electron being lost. Gamma rays are not really a type of particle. They just kind of go from high energy to low energy. So basically you have an asterisk that disappears. Oh, those ones are kind of easy. A positron is essentially a positive beta particle. So it's an antimatter. It's a positive electron. And an electron capture is actually an electron as a reactant crashing into the nucleus. Okay, so we're going to try an example of a few of these, but there's only 5 different possible options. Okay, so the first one we're going to try is radon-222 undergoing an alpha particle emission. So radon is Rn. I know we haven't used the periodic table in a while, and we're looking at isotope 222. So this is 222, and the bottom number is going to be 86 because that's what element it is on the periodic table. Okay. This is undergoing an alpha particle emission. An alpha particle is helium-2, 4. So this is what's being lost out of the nucleus. And what's happening is essentially to make this balanced, we need the top numbers to add up to the same thing and the bottom numbers to add up to the same thing. So on the bottom, 84 plus 2 is 86. And 218 plus 4 is 222. Okay, element 84, if we look on the periodic table, is polonium. So we have actually switched elements here. So despite the fact that there's a radon on this side and no radons on this side, this reaction is actually balanced because this is 222, this adds up to 222. This is 86, and this adds up to 86. So slightly different way of thinking about balancing, but it's not difficult at all. Addition and subtraction of nice whole numbers. Okay. The next one we're going to try is polonium-209 undergoing a beta particle emission. So polonium-209. Polonium is element 84. And we said down here that a beta particle is essentially an electron on the right side. So electrons have no mass, so this is almost like an anti-neutron or anti-proton. So we need to find a number that when added to -1 gives us 84, so this would be 85. And this has no mass, so this is still going to be 209. Okay, so element 85 on the periodic table is astatine. It's like a radioactive version of chlorine and bromine and iodine. So 209 plus 0 adds up to 209. 85 minus 1 is 84. Okay. The third one we're going to do is we're going to take thorium, which is element 90, and we're going to take thorium-234. And we're going to undergo a positron emission. Down here we can see that a positron is pretty much the same thing as a positive beta particle. It's literally antimatter. So we need to know what number, when added to 1, gets us 90. So the answer is 89. And again, this one has no mass, so this is still 234. So element 89 is actinium, which is AC. So, okay. So I know this is like essentially the end of Chem 2, but this is literally some of the easiest stuff we've done. As long as you know these 5 particles, there's only so many variations of it. So, if you have questions, let me know, but otherwise, thanks.